Jai Hind viewers, I am Sudhakar Dwivedi, Assistant Professor in IT Department, AKG EC, Kasyapad. So in the subsequent lectures of the Numpy, today also we will discuss very important topics about the Numpy. In the previous lectures, we have discussed how we can create the ND array objects by using the different routines in the Numpy. In this lecture also, we will discuss what are the different routines are available in the Numpy to create ND array objects in the Numpy, and also discuss about the various features of the Numpy. So as we have discussed, we have a various routines through which we can create this ND array objects. In that series, we have also a routine that is random.rand functions, through which we can create a ND array objects. So this function is used to create an array of a specified shape filled with the random values, and sampled from a uniform distribution over zeros and ones. That means this type of ND array objects have the values between the 0 and 1s, and all the values are the random, and it accepts the parameter for the dimensions of the array, like the random.rand rows and columns, and generates an array of the specified shape with random values between the zeros and ones. That means it will create an array that have the values between the zeros and ones, and if no argument is provided, it returns a single random float value. If we have not provided any value, so it will create a single random float value. Otherwise, it will create an array of the random values, and all the values are ranges from zeros and ones. This is the general syntax. So we use the random.rand function, and this is the parameters. Here, take an example. We are taking an example to understand this. So first we have to import the Numpy, and then we have used a function without using any parameters. So it can generate only the single random float values. And in this function, we have provided the parameters. We have provided a single parameters 5, and it will generate a 1D array of random float values. So the data types is float, and it will generate a 1D array here. We have provided a numerical value 5. It will create a 1D array here. And if we provided here, take an example. See this line. We have provided two parameters here. First one is 2 and another is 3. So it will create a 2D array of random floats. And if we want to create a 3D array of the random values, we have provided 3 parameters here. First one is the number of the 2-dimensional array, number of rows, and number of columns. So by this, we can create an array of the random values that is ranges from 0 to 1. As we have saw here, if we use only the rand function without any parameters, we can create only the single random float values. If we have provided only 1 parameters, it will create a 1D array. If we have provided 2 parameters, it will create a 2D array specifying the rows and columns. And we have provided 3 parameters. The first parameters, that means the first dimension, it shows the numbers of the 2-dimensional array. And this is the number of rows, and this is the number of columns. Another routine here is the full function. So using this function, using the Numpy full function, we can create an array with the desired shape and set all the elements in it to the specific values. That means whatever values we have provided, what is the values we have specified, it can fill with that particular value. So we have provided the first parameter is a shape, and the second parameter is the specified value. So here we have provided a value 5. in this function. So as I have said, we will use this function to create an array with the desired shape and set all the elements in it to the specific value. That means if we want to fill all the values with this specific value, specified value, we can use this numpy full function. So we have used this full function. The shape is 2, 3. That means 2 rows and 3 columns, and all the values filled with the 5 here. So what is the dimensions in the array? As I have said, the arrays is the collection of the homogeneous type of data elements, and it is the numpy is used to create the ND array objects, n dimensional array objects. That means it can create the n dimensional data. It can create an n dimensional data. So dimension in the numpy array is maybe 0, 1, 2, 3 and many more. So what is the 0D array in the numpy? What is the 1D array? What is 2D array, 3D array and many more. So 0D array, in the case of the numpy array, the individual element can be considered as a 0D array. So 0D arrays or scalars are the elements in the array. So element itself is considered as an 0D array in the numpy. The 1D array, an array that has 0D array as an elements. So 0D array, if an array that have this 0D array as an elements can be considered as 1D array. So what is 1D array? So 1D array is an array that has 0D array as its element. So an array that has 0D array as its elements is the 1D array. An array that has 1D array as its element, it is called the 2D array. And an array that has 2D array or matrices as its element is called the 3D array. So if we take an example here, see. So if we have an array like 1, 2, 3, this is 1D array, this is another 1D array. And if we have an array that have these 1D array as an elements, we have an array that has these 1D array as an elements, can be considered as 2D array. And if we have an array that have the 2D array as an elements, is called the 3D array. So suppose we have a 2D array. Suppose we have this 2D array 1, 2. This is one 2D array. This is another 2D array. And this is another 2D array. 3 and 4. This is another 2D array. And if we have these 2D array as an elements, this 2D array as an element, this is one 2D array and this is another 2D array. If we have these 2D array as an elements, we can consider this whole array as an 3D array here. So this is the first 2D array and this is the second 2D array. So this is the first 2D array, this is the first 2D array and this is the second 2D array. So this can be considered as an 3D array. So what I have said, the 0D array is the element itself, 1D array have the 0D array as an elements, the 2D array have the 1D array as an elements, and 3D array has the 2D array as an elements. So, as I have said, for creating the ND array objects, we have to provide the data or as a objects, and if we want to create an array object of specific data types, we have to provide the data types in the D type parameters. So Numpy offers a wide range of the numerical data types that what is available in the Python. And here is a list of the most used data types, as we can see here. Like if we want to use the signed integer types with the different bit sizes, we can use int 8, int 16, int 32 and integer 64. That means is the 64-bit integer. It can create the 32-bit integer, it can create the 16-bit integer and 8-bit integer. If we want to create the unsigned integer types with the different bit sizes, we can use uint, that means unsigned integer. Unsigned integer 16, 32 and 64. If we want to create the floating point data types with different precision labels, we can provide the float 32 or float 64 here. We can see the code here. In the subsequent lectures, we will see all these implementations. So we can create this array by using the array functions. We have provided a list here and we have provided the data type as int32. That means it will create an array objects having data types integer 32 bits. We can use the following codes. We can use these codes also, as we have written int 64 bits, int 32 bits. We can also use these short codes. So we can use these codes for the data types available in the Numpy. So as if we want to print all the data types available in the Numpy, we can use this code. So we have import numpy as np. Now we want to print all the data types available in the Numpy. So we have in the for loop for all the data types in the Numpy sc type dictionary, and all the values of this dictionary we can print. So we can have all the data types available in the Numpy. So two data types with one characters we can use to represent the data types in one characters also, like these codes. For example, if we want to specify the integer, we can use I as a one character. For the Boolean data types, we can use B. For unsigned integer, we can use small u. And for a string, we can use caps S. That means for representing the data types, we can also use this single characters. So this is the example of creating an array with the different data types. Every NumPy array is a grid of elements of the same type, as I have said. And NumPy provides a large set of the numeric data types that we can also use to construct the arrays, as I have said. And NumPy firstly guesses a data types when we create an array. But functions that constructs the arrays usually also include an optional arguments through which we can provide and specify data types as per our requirements. Here is an example. So here we have provided only a list. So NumPy np, we have imported the NumPy as np. Now we have called the array function and we have provided NumPy. And if we want to create the NumPy of the specific data types, we can provide the data type. We can provide the data type into the data type parameters. As I have provided here, np integer 64. That means it has forces to create this array of the particular type. That means if we want to create an ND array objects of a particular types, we can provide these data types into D type parameters. Either we can use this or also we can use this shortcode as I have discussed. So this is the example. So of creating the NumPy arrays with the defined data types. So here, as we can see, I have passed list and D type parameter is int8. Here it is unsigned integer of 16 bits. Here it is the 32-bit floating point numbers. Here is the 64-bit complex numbers. If we want to create an array of the complex numbers of 64 bits, here we have provided the values, all are complex, and D type is a complex 64. And if we print all these, we can have this particular output. So we are displaying here array and array data types by D type parameters. So if we want to print the data types also, we can print the array and the D types. By using the D type parameters, we can also print the data types. So here the array and this one is the data type. We can also convert the one type to another type by using the as type function here. As we have created an array here, we have created an integer array here, and now we want to convert this data type into the float. So we have created an array, and this array is stored in this variable integer underscore array. Now we want to convert the data type of this and the array objects. So we can use this as type method. So in the Numpy, we can convert the data type of an array using the as type methods. So this method as type can be used to convert the data type of already existing array. So we have passed. So this is our array that we have already created here, and we have called as type methods, and we have passed the specified data types to which we want to convert. So we have passed float here. Now this integer data type will be converted to float. See here. So first the array is created that have all the integer numbers, and then we have convert this integer array by using the as type methods to the float. See here. So in this way, by using the as type method, we can also convert the data types of the already created ND array objects. So what is the Numpy array attributes? So by using the Numpy attributes or the properties of the Numpy, it can provide the information about the arrays that we have created. What is the information? Like we can print the shape, size, data types, dimensions, and so on. So for example, we want to print the dimension of an array, we can use the ndim attributes. So there are numerous attributes available in the Numpy. That is ndim attributes is used to return the number of dimension. The size attributes it used to returns the number of elements in the array. The D type attributes, as I have said, the D type attributes returns the data type of element in the array. The shape attribute returns the size of the array in each dimension, the size of array in each dimension. And item size returns the size. Item size returns the size in bytes of each elements in the array. That means if we want to get the size of each array elements, we can use the item size, and it will return the size in the bytes. And data, it returns the buffer containing the actual elements of the array in the memory. So these are the attributes that we can use for the Numpy. So this is the example code representing the uses of the various attributes. So this is the very different arrays. As we can see, we have provided only one element here. This is a one-dimensional array, 2D array, and then 3D array. And here, by using the ndim attributes, we want to get the dimensions of these created arrays. So the dimension is, the first dimension is 0, 1, 2, and 3. Because this is the single element, individual elements, And in this array, the 0-dimensional array as an elements, and in this array, we can see this 1-dimensional array is used as an elements, and it is this 3D array, this 2D array, this 2D array, this 2D array is used as an elements. So when we have created these arrays, how we can access these individual elements or the part of the arrays? So we can use the indexes or slicing techniques to access these individual array elements or the part of the array. So array slicing is possible to extract the subset of the Numpy arrays, and array indexing can be used to access the individual elements of the array. So a bit I'm talking about the array slicing. We can provide the 3 parameters: the start parameters, stop, and step. We can provide the 3 parameters. And default start is 0, stop is the dimension size, and the step is 1. For example, if we have created an array, this is the 1D array having the 7 elements, and if we want to display only the part of this array, only the we want to display the sub array, starting from, we have provided 2 parameters here: start parameter, that is 1, and stop parameter, that is 5. But 5 will not be included. So so start is 1. That means we have to starting from this index. So this is the 0 index: 1, 2, 3, 4, and 5. So in this way, we can provide these parameters to print the subsequent element of the arrays. In the subsequent lectures, we will see how we can use this array slicing or array indexing to display the array elements of 1D, 2D, or the 3D arrays by using the array slicing and indexing. For today, that's it. Thank you so much.